cathode is a terminal in which current flows out. More specifically, it is the negative terminal in an electrochemical cell or a vacuum tube. Understanding the cathode is fundamental to grasping how these devices function. In an electrochemical cell, the cathode is where reduction occurs, meaning that positively charged ions from the electrolyte gain electrons and are deposited onto the cathode's surface. This process generates a flow of electrons that constitutes an electric current. In a vacuum tube, the cathode is a heated element that emits electrons through thermionic emission. These electrons are then attracted to the positively charged anode, creating a current through the vacuum. The design and material composition of the cathode are critical to the efficiency and performance of both electrochemical cells and vacuum tubes. The grid in a vacuum tube is usually operated negatively with respect to the cathode. This negative bias is essential for controlling the flow of electrons from the cathode to the anode. The grid, positioned between the cathode and anode, acts as a gatekeeper, modulating the electron flow based on the voltage applied to it. When the grid is negatively charged, it repels electrons emitted from the cathode, reducing the number of electrons that reach the anode. Conversely, when the grid is less negative or even slightly positive, it allows more electrons to pass through, increasing the current to the anode. This control mechanism enables the vacuum tube to amplify or switch signals. By varying the grid voltage in response to an input signal, the output current at the anode can be made to replicate the input signal with a larger amplitude, achieving amplification. The relationship between the grid voltage and the anode current is a key characteristic of vacuum tubes, determining their gain and linearity. Different types of vacuum tubes are designed with varying grid configurations and cathode materials to optimize performance for specific applications. The negative bias in the grid also helps to prevent the tube from conducting when no signal is present, ensuring that the tube operates in a controlled and predictable manner. The specific voltage applied to the grid, known as the bias voltage, is carefully chosen to achieve the desired operating point for the tube. This operating point determines the tube's sensitivity to input signals and its ability to amplify signals without distortion. In summary, the cathode serves as a source of electrons, while the negatively biased grid controls their flow to the anode, enabling the vacuum tube to function as an amplifier or switch.